If you go to the Powerball's website, you can see that the jackpot is now at $730 million. This number definitely sounds exciting, but before you rush to your local gas station and buy one of these tickets, please let me tell you some interesting stories and mathematics behind this thing called lottery. There are two major lottery plays here in the States, Powerball and Mega Millions. Powerball formed in 1992 and Mega Millions formed 4 years later, 1996. But the earliest form of lottery could actually date back to the 17th century in an Italian city called Genoa. Genoa's governor were not elected. Instead, they were randomly selected. Every 6 months, 2 slips were randomly drawn from a pile containing the names of 120 councillors. Names appeared on the 2 lucky slips would become the next city governors. Genoa's gamblers soon took action. They started putting bets on the election outcomes. But the election happened only every 6 months. Gamblers didn't have the patience, and they replaced the names of politicians with the numbers on the slips. So by 1700, Genoa was already running a lottery close enough to nowadays Powerball. Soon after, lottery had gained its popularity outside of Italy, from Europe to North America. It was favored by institutions and governments to raise funds. For example, the Harvard University built 2 college buildings with the earnings from running lotteries in 1794 and 1810. Another fun fact is that in the 2009 fiscal year, lotteries raised $17.6 billion in profit for state budgets, and 11 states collected more revenue from lotteries than their corporate income tax. So then, we know someone is benefiting from lottery. The question is, are you part of them? Or the question could be, should you play lottery? Most people with minimal understanding of probability or even common sense would say no, because we all know that the chance of winning a jackpot is close enough to 0. But there are also smaller prizes with higher chances of winning, right? So, to better answer the question, should you play lottery, you might want to take a look at the mathematical term called expectation. Expectation, or the expected value, mathematically it is defined as such, in which x is a random variable, xi's are the possible outcomes, and pi's are the corresponding probabilities for the outcomes to happen. For example, suppose you roll a fair 6-sided dice. The number showing on the top side of the dice will be the random variable x, and the possible outcomes here are 1, 2, 3, 4, 5, and 6. Since the dice is fair, the probability of each outcome to happen is simply 1/6. Then the expectation in this case would be the sum of the product of all the possible outcomes with its probability. Now, the number 3.5 is definitely not a value we expected. 3.5 is not even in the list of all the possible outcomes. Then, why is 3.5 the expected value? Let's roll the dice again. For simplicity, suppose you get $10 if you roll a number 6 and nothing otherwise. So the expected value based on the formula is indeed equal to 5/3, or roughly $1.67. Now, where does this $1.67 come from? You are supposed to get either $10 or nothing at all. This $1.67 comes from the assumption that if you roll the dice for many times, say 600 times, given the probability of rolling a 6 on a fair dice is 1/6, most likely you will roll a number 6 for 100 times. So then you could get $1,000 after you roll the dice for 600 times. So then on the average, you make $1.67 each time you roll. Expected value is not the value you would expect to happen. Expected value is the average value in the long run. Now, for that dice game, if you need to pay $3 or $4 to roll that dice, would you do that? Now, we see what the expected value means. Let's figure out what is the expected value when you play that Powerball lottery. Powerball's website has all the odds for different winnings. The odds for winning any of these prizes remain the same over time. The only thing that's changing is the grand prize, namely jackpot. Let's assume jackpot is at $20 million, then the expected value is not that hard to compute. You will just have to multiply the price with its odds. Right, your $2 bet has an expected value of a quarter plus a dime and roughly 4 cents. But what if the jackpot price is more than $20 million? For example, the most recent jackpot was $730 million. If we do the algebra again, the expected value is actually $2.82, which actually sounds like a good investment, but not really. The 730 million jackpot sounds insanely high in the case that you are the only winner. In the other word, everyone else besides you has to lose. What is the probability of this? From a lotteryreport.com, there are over 114 million tickets sold for that last Powerball draw, which is saying that one in all these 114 million tickets wins it all if and only if everyone else loses. Well, what is that probability? It's not that hard to figure out. Probability of one ticket losing jackpot is close enough to 1, which is 0.9999. And since each ticket is independent, everyone besides you loses in that joint night would be 0.999 raised to the power of the number of tickets sold minus 1, which is 0.676, which is saying that the chance that none of these 114 million ticket holders will win is just about 68%, which is also saying that there is a decent 32% chance that at least one of these ticket holders besides you will win the jackpot as well. Just as when you believe you are the favored one by God, and there's still a good 32% chance that someone else could take away much of your rare fortune. So now, should you play Powerball? I would say no, you shouldn't. Hey Daniel, what's up? What? One person took it all? $730 million. Wow. Hey, wait, Daniel. Can you do me a favor? Can you go to the gas station real quick and give me a couple Powerball tickets, please? Thank you. Okay, should you play Powerball? Well, probability and expectation are telling you not to, but most people tend to overestimate the probabilities of unlikely events, like hitting the jackpot. So, for the next video, I will talk about the rare events in our daily life.